So in today's video I have brought you a very nice problem. So the question, we are going to find the last two digits of this huge number. Okay, so we have the sum as k goes from 1 to the 2021 k factorial. Okay, all is raised to the exponent of 2021. Okay, what's the mean last two digits? The last two digits means when you divide the number by another number, you find the remainder. That remainder is the last two digits. Okay, let's check this one how it goes. Okay, so we have this sum as k goes from 1 to 2021 k factorial all 2021 equals 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial plus 8 factorial, and all the way down until we get 2021 factorial. All is raised to the exponent 2021, like this. Okay, now we are going step by step until we finish this problem. Before we start working on this one, we check which module is convenient to reduce this one to the lowest value possible in order to find the remainder easily. Okay, it's the convenient value of factor which makes all the bunch of the values 0 as a remainder. I see it here 10 factorial, because 10 factorial, here is number 10 in front. If you reduce this one to 10, is automatically 0. So we need to extract another 10 as a factor in order to get the remainder 0, in order to make the divisibility occur when you divide by 100. Okay, so because if you take 10 factorial, because 10 factorial equals 10 is multiplied by 9 is multiplied by 8 by 7 6 5 4 3 2 and 1. Okay, so we already have 10 here. We need to find another 10 by combining these two values, by combining two numbers from here. Okay, you get this 10 is multiplied. Let's take this number 2 here in front. Take number 5. 2 is multiplied by 5 is given as 10. 10 is multiplied by 10 is given as 100. So this one is multiplied by the bunch of the numbers. So since we get 100 here, so you get, when you divide this one, you get 0 as a remainder. Okay, so let's move on to the next value after this one, which is 11 factorial. 11 factorial will be written 11 is multiplied by 10 factorial. Okay, we already have 10 factorials here. Since 10 factorial is the same value is repeating here, because we know 10 factorial is a congruent to 0 mod 100. Okay, so the same thing here, because as you going up in the factorial values, you get always 10 factorial is repeating here. Okay, so 12 factorial, you get 12 is multiplied by 11 factorial. You get 12, 11 factorial equals 11 is multiplied by 10 factorial. Always you get 10 factorial available here. We found out this 10 factorial is 0, is a congruent to 0 mod 100. Okay, which means after this value here, which you're going to put 9 factorial plus 10 factorial, which means up from here to here, all 0, all is a congruent to 0 mod 100. Okay, so we are going to keep just 9 objects here, from 9 factorial down to 1 factorial. Okay, so now it's more clear here. Now we need just to calculate this bunch of these numbers to find the remainder when you divide these numbers by 100. Okay, let's call this one as a capital A is a congruent, which is this one, is a congruent to 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial plus 8 factorial plus 9 factorial plus 0, because we find the remainder 0, all other terms from 10 factorial up to 2021 factorial. Okay, this one is mod 100. Okay, Now we need just to calculate these numbers to find what's the remainder of this one. There is a trick to make it more easier. If you calculate from here to here, you get the value of 873. Okay, 873 is the same as 800 plus 73. Okay, this is 0, is a congruent because 800 by 100 is given as 0. I'll get the remainder 73 plus the rest of these three numbers. So let's check the remainder of this one. 7 factorial, it's more clear value, it's more known value. 7 factorial is the same as 7 is multiplied by 6 factorial, which is 7. 6 factorial is a 720. Okay, 720, if I'm going to split this 720 into two values, I get 700 plus 20. 700 is 0, I will be left with 20 is multiplied by 7, which is 140. I get here 140 is a congruent to 40, because 140 equals 100 plus 40. Okay, because 140 equals 100 plus 40. I will be left with 40 here. Let's put it next to it. This number is 40 as a reminder. Let's check 8 factorial. 8 factorial is the same as 8 is multiplied by 7 factorial. 7 factorial, we already found the remainder is 40 here. 40 is multiplied by 8, which is 320. 320 is a congruent to 300 plus 20. 300 plus 1, which is 20. Okay, plus put this 20 here as well. Let's check 9 factorial. 9 factorial is the same as 9 is multiplied by 8 factorial. We already found the remainder of 8 factorial is 20. 20 is multiplied by 9, which is 180. 180, which is 100 plus 80, which is the remainder. You get 80 here. Let's put it next to it, 80. Now we are going to add all these values as a remainder. Okay, so you get 70, you get 40 is 40 plus 20, which is 60. 60 plus 80, which is 140. Also 140 is a congruent to 100 plus 40. You get 100 cancelled out, I will be left with 40. Now 40 plus 73. 40 plus 73, I get 3, I get 11 here. 111 and 113. 113 is the same as 100 plus 13. So I get a remainder 13 here. Okay, so all of this huge number, which is from 1 factorial up to 21 factorial, we found the remainder 13 when we divide this number by 100. Okay, now let's reduce this one, and now let's take this value as a remainder and replace it here. Okay, with 13 mod 100. Okay, all is raised to 21. Okay, now I get capital A is a congruent to 13, all is raised to 21. Okay, which mod 100. Now let's work out with this one here. I get 21 equals 20 is multiplied by 1 plus number 1. Let's take this one on the form of the exponent. I get 13 to the 21, which equals 13 to the 20 plus number 1, which equals 13 is multiplied by 13 to 21, which is 20, all to 1, like this. Okay, now we are going to reduce this one to mod 100. So we get 13 all is raised to 20, okay, as a power, equals 13. We know also 20 is 4 is multiplied by 5, which equals 13 to the 4, all is raised to the number 5. Also this one equals 13 square another square, all is raised to the 5. Let's reduce this one to my 100. I get 13 square, which is 169. 169 square, all to the 5. 169, you get 100 plus 69, we get a remainder 69 here, square, all to the 5. So I'm going to use the trick in order to reduce this number to the smallest value possible. Since I have a square here, I'm going to put this one as minus 31 square, because we know 69 equals 100 minus 31. 100 it will be reduced to the 0, mod 100. I will be left with minus 31 as a remainder. With this square, so we know 31 square, which is 961, all to the 5. We know when we reduce this one to the mod 100, you get 61 as a remainder. Okay? So I get here 61, all to the 5, mod 100. Okay, this one all the way down is mod 100. This one is a little challenge to find the remainder of this one, because the problem, we have the power add here 5. So this one, if you use the calculator, you will have a huge number. So we don't want to do it that way. We are going to use the binomial expansion. Is better. Let's take the general formula for the binomial expansion first. I get 1 plus x to the n equals 1 plus n is multiplied by x plus n is multiplied by n minus number 1 over 2 factorial x squared plus n is multiplied by n minus 1 is multiplied by n minus 2 all over 3 factorial x cubed, and take this one all the way down like this. Okay, so I'm going to use the same thing that I have here. So we know 61 to the 5th equals 1 plus 60 to the 5th, like this. Okay, so I get by using this formula of the binomial expansion, I get number 1 plus 5 is multiplied by 60 plus 5 is multiplied by 4 over 2 factorial is multiplied by 60 square plus 5 is multiplied by 4 is multiplied by 3 factorial 60 cubed. This one is going all the way down. Okay, if you try to reduce this one to mod 100, okay, to mod 100, you get this one 0, this one 0, and all the way down. Why is 0? Because we have 0 at the end. We try cube this one, always you get this number is divisible by 100, okay, which will be 0. This one 0. Let's check with this one. 5 is multiplied by 60, which is 300. This one is also 0. I will be left with number 1 here. So which means it's more simple now. 61 to the 5th is a congruent to 1 mod 100. I get number 1 as a remainder. Okay, now I found this value which I was looking for, which is this one. So now thus I get 13 to the 20 is a congruent to 61 to the 5th, which is a congruent to 1 mod 100. Okay, just take this value of 1320. Now take this value of 13 to the 2021 as I have before, which equals 13 is multiplied by 13, because 2021 we said 20 plus number 1. Number 1, take this one outside. 13 is multiplied by 13 equals to 20. 13 to the 20 all to the 1 as an exponent. We already found this remainder. This one is 1. If you try to reduce this one to mod 100, I get here 13 1 all to the 1, which is 13 mod 100. Okay, now we get the last 2 digits. We found 13 as a remainder, which means the last 2 digits is 13. So I have ended this video. Don't forget to hit the subscribe button and support the channel. Thank you for watching, and you have a nice day and enjoy the rest of your day. Bye.